Hey everyone, before we get to the triangle, the new lesson on 4-1, I want us to finish up the symmetry part from 3-3 and 3-5 notes. So let's quickly do that. So remember, we just got through doing rotation. And so now we're going to see if a figure has what's called symmetry. So you guys all know what symmetry is. Um, and so let's take a look at different types of symmetry here. So you can have a line symmetry where if you have an imaginary line that you can reflect and it gives you back the same shape. So it's kind of like a reflection, right? So that triangle, if you draw a line through the middle of the triangle, it reflects back to itself, so that has a line symmetry. Or something can have, a figure can have a point symmetry if you can rotate about a fixed point by 180 degrees. And then, so typically what that means is if a figure looks the same upside down. So if I take this N, and here is the center, and if I rotate that 180 degrees, you get that same shape back. So it has a point of symmetry. And then a rotational symmetry, a figure will have that if you can rotate it and it's the same figure, but you have to rotate the figure by less than 360 degrees. Okay, so think of it like a pinwheel. So here, I can rotate it by this amount and you would get the same figure back. And so that shape has a rotational symmetry. So let's do some examples. So here, what we want to do is to see if a figure has a line, point, or rotational symmetry. And some figures can have all of it. All right, so let's check to see if number 1 has any of the symmetry. Well, let's see, I can draw a line through the center and it looks the same on both halves. I can even do it across this line and it's the same, across. So it definitely has a line symmetry. So let's see if it has a point symmetry. So if I put a point here and if I rotate that 180 degrees, so I would move it 180 degrees and sure enough, we would get the same figure back. So it does have a point symmetry. And what about rotational? So once again, I can rotate it. I can move this point to this point here, and it would still be the same shape. So here I also have a rotational symmetry. And if you have a difficult time seeing the rotation, what I would suggest you do is to get a little piece of wax paper and then just trace the figure and see if you rotate it by a certain amount, you can still put that shape back on to the original drawing. And if you can do that, then it will have a rotational symmetry. Okay? All right, so number 2. So here, triangle definitely has a line of symmetry. There's another line right here, and there is another line right here. Okay, so it definitely has a line of symmetry. And what about the point? So here, remember, you are going to be rotating it 180 degrees. All right, so that means that this point comes all the way down to here. So it would look like this. And that certainly is not the same image as we had before, so it doesn't have a point symmetry. But notice that I can rotate this point to this position here, and would we have the same rotation? So would we have the same shape? Okay, so every point that you can move up, so I can rotate it by 120 degrees, and that certainly would give you the same shape back. All right, so it has a rotational symmetry. All right, and for number 3, it looks almost like it would have a line symmetry, but I can draw a line through here, and it does not, it's not the same on both sides. And so, and if I can look over this way, it still doesn't. And what about if I do it diagonally? Okay, and it looks kind of like it's the same half, but if you actually fold it over, they're not going to match exactly. So this one, a parallelogram doesn't have a line of symmetry. Okay, what about a point? So if I rotate this 180 degrees about the center, it will go back to its original shape, and so it definitely has a point symmetry. And what about rotation? So I can rotate it 180 degrees, right? And it would still have a rotational symmetry. Okay, so typically when it has a point symmetry, it's always going to have rotational symmetry, but not the other way around. Just the fact that it has a rotational symmetry doesn't mean that it has a point. But if it does have a point, then it actually has one rotational symmetry. So keep that in mind. All right, so here we have a right triangle, and I can try to draw a line. It's not the same on both halves. So what about this way? Nope. And I can try to draw a line, but it's certainly not going to be symmetrical anywhere as we try to draw a line. And so it does not have a line symmetry. And what about a point? Well, part of the problem with this is that where do we put the center? What do we mean by the center anyway? So, and because we really can't define what the center is for this triangle, it really doesn't have a point symmetry, but let's just say that you kind of guessed where the center would be. If we rotate it 180 degrees, it certainly is not going to give you that same triangle back, so it doesn't have a point symmetry. And what about rotational? Usually, a triangle could have a rotational symmetry, but here, none of the sides are the same. And so every time we move that triangle, even at 120 degrees, it's not going to give us the same. So this one has no symmetry. All right, so now we get into some fun shapes here. So a star. Okay, so if I draw a line through the center, it certainly has a line symmetry because I can fold it and it would completely overlap. And I can draw a line through here as well. So at each of the corners, I can draw a line. If you fold it over, it would be the same on either side. So it does have a line symmetry. What about a point? So remember, a point symmetry, if you can put a point in the middle and rotate it 180 degrees. So what does that mean? That means this point is going to come here. Okay, and so your star is really going to look more like, I don't know if I'm going to be able to draw it well. Okay, so it's going to end up looking like that. Okay, so it's not the same shape, so it does not have a point symmetry. All right, but I can rotate this point not to here, but to this point here. And that means this point moves to here. Okay, so it does have a rotational symmetry. And once again, if you are having a difficult time sort of seeing that, you can certainly use a wax paper and rotate it around. Okay, the next one. I can draw a line through here, but notice that if you fold it over, it's not going to overlap. Neither will this line here. And then you might think that, well, what about the diagonal line? And certainly this part is not going to match up. So it does not have a line of symmetry. What about a point? So can I start here at the center and then move it 180 degrees? Yes, it would come back to its original shape. So it does have a point symmetry, and that means it's going to have at least 180 degree rotational symmetry. Okay, so I know that some people will have difficult time seeing it. So once again, try to use a wax paper if you can. All right. And then, so let's see if the figure looks like it's going to have a line of symmetry. Okay, and then if it does, so I want to write how many lines it would have. All right, so here I can draw this line here, and it would, excuse me, it would overlap if you fold. And the same thing goes for this line here, this line here, and that line there, and that line, right? So every one of those lines are going to, if you fold it along that line, then you would have the same shape. And so this one does have a line symmetry. And so here I have 1, 2, 3, 4, 5 distinct lines. Okay, so that means that we have 5 lines that we can draw. Okay, so for number 2, here's a smiley face, and I could draw a line right through the vertical, and if you fold it, it would be the same, or the shape would overlap, and so it does have a line of symmetry. And the question is, does it have any more than that? The answer is no, because if it was just a plain circle, then it would have infinitely many. But because we have the eyes and the mouth, the only place where it's going to overlap completely is going to be through that vertical. And so we just have that one line. And what about number 3? Does this have a line of symmetry? Certainly not vertical, and certainly not the horizontal. And the question is, what about like the diagonal? If you fold that, do you get the same exact shape? And the answer is no. It may look like it if you, but if you actually trace that folded, it's not going to overlap completely. So here, this does not have a line of symmetry here. And this shape, it's not, doesn't have any of the sides that are the same. And so it's not going to have any kind of line of symmetry. It doesn't look the same on each half, no matter what line I draw. So here, the answer is no. Okay. We are actually going to skip the order and magnitude in rotational symmetry. So that's all we are going to be doing for this particular lesson. All right, so now I'd like you to go ahead and watch the 4-1 lesson. All right, thanks.